Production. Cheese is produced by microbial fermentation. Lactic acid bacteria are used to lower the pH of milk and convert the sugars into lactic acid. As a result, the milk proteins curdle to form cheese. This process, driven by starter cultures of bacteria and sometimes fungi, is crucial for transforming milk into a preserved, flavorful, and texturally complex dairy product. The preparation of milk begins with standardization, which adjusts the fat content, followed by pasteurization to kill harmful bacteria and cooling to prepare the milk for starter cultures. Fermentation and coagulation then take place by adding lactic acid bacteria as starter cultures for fermentation and adding rennet to coagulate the milk proteins. The curds are then handled by cutting, cooking, and draining the whey. Next comes whey removal and forming, which involves milling and salting the curds and pressing them into blocks. After this step, the cheese undergoes aging or maturation under controlled environments where microbial and enzymatic action develops flavors and textures. Finally, packaging is carried out by cutting, vacuum sealing, and preparing the cheese for distribution. There are different types of cheese. Fresh cheeses are unaged, have a high moisture content, and are typically soft, spreadable, and mild in flavor. Soft ripened cheeses have a soft interior and a white, bloomy rind, which is a thin, edible layer of mold, and they are known for their creamy texture and earthy flavor. Semi-soft cheeses have a slightly firmer texture with a smooth, pliable interior. Semi-hard cheeses are firm and dense with a smooth, sometimes crumbly texture. Hard cheeses are aged for a long time, resulting in a dense structure and intense flavor. Microorganisms play an important role in cheese production. Lactic acid bacteria act as starter cultures by converting the lactose in milk into lactic acid, which curdles the milk and preserves the cheese. Lactococcus lactis is used in making soft and semi-hard cheeses such as cheddar and Gouda. Streptococcus salivarius subsp. Thermophilus is a thermophilic bacterium used for cheeses cooked at high temperatures like mozzarella. Lactobacillus species are important for ripening aged and hard cheeses. Propionibacteria produce the carbon dioxide gas that forms the characteristic eyes or holes in Swiss cheese and give it a nutty flavor. Brevibacteria create the orange color and pungent aroma on the rind of washed rind cheeses such as Limburger. Fungi are also important, such as molds like Penicillium roqueforti, responsible for the blue veins and sharp flavor in cheeses like Roquefort, Stilton, and Gorgonzola, and Penicillium camemberti, which creates the soft, white rind on cheeses like Brie and Camembert. Yeasts also contribute to ripening and flavor development, especially in mold or bacteria-ripened cheeses. Bread production. Bread is produced by microbial fermentation, primarily involving yeast Saccharomyces cerevisiae, which ferments sugars in flour to produce carbon dioxide and ethanol. The carbon dioxide gas gets trapped in the gluten network of the dough, making the bread rise, while ethanol evaporates during baking. Lactic acid bacteria may also participate in sourdough fermentation, contributing flavor, acidity, and preservation. The steps in bread production begin with flour preparation. Wheat flour contains the proteins glutenin and gliadin, which provide the gluten structure. Other ingredients include water, yeast, salt, sugar, and fats or oils. During mixing and kneading, flour proteins and starch are hydrated, the gluten network develops to make the dough elastic, and the yeast and nutrients are evenly distributed. Fermentation, also called proofing, follows, in which yeast ferments sugars to produce carbon dioxide and ethanol. The dough rises as carbon dioxide is trapped in gluten. In sourdough, lactic acid bacteria such as Lactobacillus species produce lactic and acetic acids that enhance flavor and shelf life. The dough is then punched down and shaped to remove excess gas and redistribute yeast and nutrients for uniform fermentation. Shaped dough undergoes final proofing, which is a second rise that ensures better crumb texture and volume. Baking begins with rapid yeast activity called oven spring, during which starch gelatinization and gluten protein denaturation stabilize the bread's structure while ethanol evaporates. Cooling is necessary to prevent sogginess and improve texture before packaging. Packaging is done by wrapping bread in plastic or paper to maintain freshness, and sometimes modified atmosphere packaging is used for extended shelf life. Bread comes in several types. White bread is made from refined wheat flour and has a soft texture. Whole wheat bread contains bran and germ, making it higher in fiber. Sourdough is fermented with wild yeasts and lactic acid bacteria, giving it a tangy flavor. Multigrain bread is made from a mixture of grains and seeds and is nutrient-dense. Flatbreads such as naan, pita, and chapati are often unleavened or lightly leavened. Specialty breads include rye, gluten-free breads, and enriched breads like brioche and challah. The microorganisms in bread production include yeast, mainly Saccharomyces cerevisiae, which is the primary leavening agent that produces carbon dioxide and ethanol. In sourdough, lactic acid bacteria such as Lactobacillus sanfrancisensis, Lactobacillus brevis, and Lactobacillus plantarum contribute flavor and preservation. Other less common microbes include the yeast Candida milleri, which coexists with lactic acid bacteria in sourdough, and Leuconostoc species, which provide mild acidification in early fermentation. Fermented vegetables, olives. Olives are naturally bitter due to oleuropein, a phenolic compound. Fermentation removes this bitterness and preserves the fruit. The process relies on lactic acid bacteria and sometimes yeasts, which convert sugars into lactic acid. This lowers the pH, enhances flavor, and prevents spoilage, while salt brining aids preservation. The steps in olive fermentation begin with harvesting and sorting, where olives are picked at green, semi-ripe, or black stages and sorted to remove damaged fruits. Preparation involves washing to remove dirt and debris, and sometimes lye treatment with sodium hydroxide to hydrolyze oleuropein and speed up debittering, followed by rinsing to remove excess lye. Brining then occurs, where olives are submerged in a salt solution, typically 6–12% sodium chloride, which inhibits spoilage organisms and favors lactic acid bacteria. During fermentation, lactic acid bacteria metabolize sugars into lactic acid, lowering the pH to below 4.5. Yeasts may coexist in the brine, contributing to flavor and aroma, and some yeasts also degrade oleuropein to enhance debittering. Fermentation can last from several weeks to months depending on the method. Flavor development and debittering continue during storage. Microorganisms involved in olive fermentation include Lactobacillus plantarum, which is dominant and produces lactic acid, Lactobacillus pentosus, which plays a key role in debittering and pH reduction, Leuconostoc mesenteroides, which contributes to early fermentation, and Pediococcus species as secondary fermenters. Yeasts such as Candida boydini and Saccharomyces cerevisiae also assist in flavor and aroma development. There are different types of fermented olives. Greek-style olives undergo natural fermentation by direct brining, leading to slow lactic acid fermentation and strong flavor. Spanish-style olives undergo lye treatment to remove bitterness, followed by brine fermentation. California-style ripe black olives are treated with lye, oxidized, and then canned, though they are not always fermented. Fermented vegetables, cucumbers. Cucumber fermentation involves using lactic acid bacteria to preserve cucumbers in a saltwater brine, creating probiotic pickles that are sour and tangy rather than simply using vinegar. The process uses naturally occurring bacteria on the cucumber's skin and requires an anaerobic environment to prevent mold growth. Pickles produced this way are fat-free, cholesterol-free, low in calories, and a good source of vitamin K. The microorganisms involved include Lactoplantibacillus plantarum, Pediococcus, Leuconostoc, and other Lactobacillus and Pediococcus species. The steps in cucumber fermentation begin with harvesting and sorting, where fresh cucumbers are picked at the immature stage when they are small and firm, then washed and sorted to remove damaged or overripe fruits. Brining follows, where cucumbers are submerged in a brine solution containing 5–8% sodium chloride. Salt draws out water and sugars from the cucumbers through osmosis and selects for lactic acid bacteria while suppressing spoilage organisms. Fermentation then occurs as lactic acid bacteria ferment cucumber sugars into lactic acid, lowering the pH to about 3.5.